champs, we're back in continuation to our chapter on real numbers. Today we'll be seeing a very important sum. You can find that in board exam year on year, okay, and that is prove that root 2 is irrational. Okay, so what do I have to prove is root 2 is irrational. Now if you go back to my first session, I have explained what irrational numbers are. But typically, the roots of all the prime numbers are irrationals. Even your pi is an irrational number. Okay, so we have to show that root 2 is irrational. Now before I begin, I know there are these reflections on this part of the board, and I'm sincerely sorry for that. If you're not able to see that clearly, I'll try to get those fixed, but focus should be here with me because you are here with me. Okay, so root 2 is irrational. Now what do? We prove this by method of contradiction. Now what do we mean by method of contradiction? Method of contradiction means I say, okay, root 2 is not irrational, let us say it is rational, okay, and then I go about maneuvering it in a manner where I reach a result wherein I say what I had supposed is contradictory to what I have found, and hence my assumption was false. Okay, so this is the method of contradiction. Okay, so it's as simple as saying, if I have to prove that the cow is a dog, so I go by saying, let us say that the cow is a dog, okay, and then I say that the cow, or which I assume to be a dog, has horns. No, it does not have horns. Okay, is it white in color? Maybe yes, maybe no. Does it have a tail, hairy tail? No. Okay, so then I come to a conclusion that the dog which I had supposed to be a cow is actually not a cow because the parameters are not matching. That is the method of contradiction. Okay, now here what I'll do is I'll say, let us suppose that root 2 is rational. Okay, now in yesterday's session I had told you in my very first session on numbers that if a number is rational, you can write it in the form p by q. So root 2 can be written in the form p by q, where q not equal to 0, p and q are co-prime. Okay, use similar alphabets, so smaller one here. Now this is very important, okay, that p and q are co-prime. Okay, now what we do is we square both sides. So squaring both sides. So you have root 2 square equal to p square by q square. This is root 2 square is 2. The root 2 and square will cancel. P square by q square. Therefore, q square equal to p square by 2. Okay, so q square we brought it here, the 2 came here in the denominator. Okay, so what do we see here is q square is p square by 2, which means therefore 2 divides p square. Now we have a theorem which says that if a number divides the square of a certain number, that number will also divide the other number. Therefore 2 divides p. Let us take an example. Okay, so let us say that this is 4. Okay, so 4 square is 16. So 2 divides 4 square, which is 16. Now if the number is 4, 2 also divides 4. So which means if a certain number divides the square of another number, that number also divides that number. So 2 divides p square, hence it also divides p. Okay, so if this is so, what I can do is, if 2 divides p square, let me say let p is equal to 2 times p1. Okay, because 2 divides p, which means p has 2 as a factor. Okay, so if p has 2 as a factor, I can very well write p as 2p1. Okay, now what I do is I put this in my equation 1. So let us say this is 1, this is 2. So putting 2 in equation 1. Okay. So here you have q square equal to 2p1 square upon 2. So instead of p, I have put 2p1. Okay. So q square equal to 4p1 square by 2. So 2 square is 4, p1 square is p1 square. So this becomes q square equal to 2 1s are 2 2s are 2 p1 square. Okay. So q square equal to 2 p1 square. Therefore, p1 square equal to q square by 2. Okay. So now we have, therefore, 2 divides q square. Therefore, 2 divides the number, which is q, so 3 divides q. Now you see 2 divides q and 2 divides p. Therefore, 2 is a common factor of p and q. But that is not true. Why? Because for rational numbers, p and q have to be co-prime. But in this case, they have 2 as a factor. But this is in contradiction to the definition of rational numbers. Okay? Therefore, our assumption is false. Therefore, root 2 is not rational. Therefore, root 2 is irrational. Done. So, we're done with this. Okay. Now, let me get back to you on the next session, which will be on HCF, LCM, and how do we further solve sums of these types.